All right, so we're going to talk about oxidation and reduction. And a lot of people in a lot of places it's called redox, okay? So you could call it reduction and oxidation. It would make a lot more sense if it was called that, and redox. But basically, oxidation and reduction, we need to know a little bit about it, okay? The driving force for redox reactions, I'm going to put that right on here, driving force, because different reactions happen because of different reasons, and you know, some might be to absorb energy, to release energy. The driving force for redox reactions is the transfer of electrons, and I'm going to represent that. It's on the Emily. It's on the homework page tab, and then scroll to the bottom. It should say oxidation reduction. Okay. So the driving force for redox reactions is the transfer of electrons. When you think about transfer electrons, I would hope that we recall back to, let me go ahead and just go to the next slide. Transfer of electrons, and I'm going to write that again, that we have a positive, or in other words, a cation, and a negative anion. So a positive and a positive, which is a cation, and a anion, which is of course a negative. Now usually this happens in redox or in oxidation and reduction with a metal ion, and the metal ones are the ones that are going to form those cations, right? Because they're located on the left of the periodic table, and a non-metal. Okay, so that's your anion versus your cation, transfer of electrons. Now, the terms oxidation and reduction are something we want to take a quick look at as well. Thank you very much. So, the terms, oxidation is a process where an ion becomes more positively charged. So you can actually have a positively charged thing and it becomes even more positively charged. But again, basically, if it loses one or more electrons, that's where it becomes positively charged. So if I give an example, obviously, if you have magnesium and it forms Mg with a plus, or for example, magnesium with its 2 plus, which is what it normally wants to form because it's in the alkaline earth metals, this is the oxidation. Okay? Oxidation is a process where it becomes more positively charged. Reduction, process where an ion becomes less positively charged, and of course it'd be gaining an electron. Now, there's a little mnemonic to remembering oxidation and reduction, and that mnemonic is oil rig. Okay, so oxidation is a loss of electrons, reduction is a gain. And again, you remember that when something forms a positive charge, that's a loss of electrons, versus, again, let's say we had chlorine forming Cl minus, that's a gain of electrons. So it's nice, this little mnemonic, oil rig. Oxidation is a loss of electrons, reduction is a gain. So oil rig, nice little I guess mnemonic to remember about oxidation reduction. Okay, so let's move on, and we're going to kind of get into this oxidation numbers. Okay, and again, this is all on my website, so it's something you can take a look at. All right, oxidation numbers. Oxidation numbers are a little bit different than charges. If you recall last year when we talked about charges, writing positive and negative charges, I tried to remind you to say, you know, if magnesium was forming its charge, it was Mg with a 2 plus charge. This is a charge, okay? Oxidation numbers, and remember last year, I didn't mind if you wrote +2. I said that was kind of okay, but it's really not right, because the way that we represent oxidation numbers is writing the charge, the plus or negative, in front of the number. Okay? So just so you know that this is the way that we write charges, positive or negative, and this is the way that we write oxidation numbers. Now you're going to see that some of them are exactly the same as the charges, but some of them are a little bit different. Okay? So oxidation numbers. And I'm going to actually just pause that right now.